Welcome to qnawire.
So over here we're given the following equation and we want to know what is going to represent x. So in this case, this is going to represent the scenario in which we're going to have a certain charge q. Let me put it in red. A charge q that is going to be moving with a certain velocity v. And we're going to have a magnetic field that is going to be perpendicular to that velocity on the whole space. Let me just try to fill it out. So in this case, what we know is that since the magnetic field is going to be perpendicular to the velocity of the charge, what is going to occur is that the force due to the magnetic contribution is going to be equal to qvb, q times velocity v. Remember that the force is equal to q times the cross product of v cross v. In this case, if they are perpendicular, you're going to have just this term surviving. And at the same time, in this scenario, we're going to have that the movement of this particle is going to experience a centripetal acceleration. Which is going to be corresponding to the right-hand rule. In this case, the centripetal acceleration is going to tell us that the acceleration is going to be equal to the force divided by m, and which is equal to v squared divided by r. So from here, we can calculate that r is equal to mass times velocity squared over the force. Thus, r would be equal to, let me go down a little bit, r would be equal to mass times velocity divided by q times v. Thus, the value for the magnetic field, in this case, we're going to take the absolute value of q, since over here we have magnitudes, actually magnitude of both q and magnitude of the velocity on this equation. But in this case, the velocity, it really doesn't matter for our purpose. So we're going to end up that v would be equal to m times velocity divided by absolute value of q times r. So in this case, the correct answer is going to be the radius, VA. And just for illustration, if the charge is positive, what is going to occur with the movement is going to be that we're going to have a circular motion on this direction. And if the charge is negative, what is going to occur is that the motion would be on the other side, going like this, since the field is always going to be pointing down. And with that, it would be all. Thank you very much and have a good one.